In this video, we'll be looking at sample space. Sample space is the collection of all possible outcomes when an event occurs. So let's say we take a coin and we flip it. It can either land on heads, which I'll call H for short, or land on tails, which I'll call T for short. So from one coin toss, the sample space is H or T. While that might seem simple enough, the sample space gets more challenging to see for additional trials. We can use a diagram called a tree diagram to help us easily visualize the sample space. Let's say we flip another coin. If we first got heads, our next flip can give us heads or tails. And if we first got tails, our next flip can give us heads or tails. We can follow each set of branches to determine the sample space for two coin tosses. Here we have heads followed by heads, then we have heads followed by tails, then we have tails followed by heads, and finally we have tails followed by tails. The more trials we complete, the more helpful a tool like a tree diagram becomes to make sure we're not missing any options. If we flip one more time, it will land on heads or tails. Following our sample space, we get heads, 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 tails, heads, tails, heads, heads, tails, 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 heads, heads, tails, heads, tails, 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 heads, and finally, tails, tails, tails. Being able to see the sample space in this way will be very helpful as we dive more deeply into probability. Okay, let's say instead of a coin, we toss a pair of dice. A die has 6 faces, so looking at the possibilities of tossing one die using a tree looks a bit messy. Now, throw another die in the mix, and each branch would get 6 more branches, a tree that would confuse and overwhelm even the best of us. Another tool to look at sample space might work better here. A 2-dimensional grid can be used when only 2 things occur. In this case, 2 dice were tossed. The grid works better than the tree here because with several outcomes within each trial, it's simply easier to look at. We list outcomes 1 to 6 on one axis representing the outcomes for our first die, and outcomes 1 to 6 on the second axis representing outcomes for the second die. We then create a grid that will allow us to see the combined outcomes for both dice. In our first row, we have 1 1, 1 2, 1 3, 1 4, 1 5, and 1 6. Similarly, we fill out our second, third, fourth, fifth, and sixth rows. Since there are 6 rows and 6 columns in this sample space, 6 times 6 tells us that there are 36 outcomes in all. Let's see how examining the sample space in this way can help with an example probability question. When we roll 2 dice, what is the probability of getting at least 1 6? We can go into our sample space and circle all outcomes that have at least 1 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 outcomes have at least 1 6. 11 out of 36, the total number of outcomes in our sample space. Let's summarize what we've learned in this video. Sample space is a collection of all possible outcomes. A tree diagram helps us to visualize the sample space for multiple trials. A 2-dimensional grid helps us to visualize sample space for 2 trials. Number of outcomes in a sample space tells us the denominator for probability.